Okay, the graph I want to do we'll just go from -2 to 2 for the time being, but we could use any numbers. We could relabel the graph. And this is not going to be one of your fundamental functions, it's going to be this. Okay? Now I want to take every point of this graph and raise it 1 unit. Okay? Now you don't have a table. If you did, you could just add 1 to all your y values, right? Okay? And then you can just plot those points. But you can do it graphically. You say, okay, we'll take this point, this point, this point, this point, this point, this point, and this point. And I'm going to say that, well, 1 unit, if that's -2, that's -1, so this arrow has a length of 1. I'm going to make that one yellow. So all I have to do to raise this graph 1 unit is take this arrow and affix it to every one of these points. Wherever the tip of the arrow is, that's where the graph is going to be. Okay? So, 1 unit, okay, it's that long, that long. I'm going to keep looking back at it because I don't want to get it. There'll be some kind of progression in the length that I don't want. Probably will be anyway, but I'm trying to minimize it. Okay. So, I do those arrows. Okay. I indicate that this arrow corresponds to +1. Okay. So, yeah, you can put +1, +1, +1, +1, +1, +1, +1. And then I can sketch a curve through these points. That's going to look about right. Okay? Okay, so that's the way it looks. So, that was tough, wasn't it? Okay, everybody can do that, right? And now when I say do that, I don't mean draw a curve up here with nothing. I mean draw these arrows, indicate the arrow on an axis so that we know what you're doing. Okay? Okay. So that's should be feasible. Now, if I wanted you to move 3 units to the right or left, you do the similar thing, but the arrow would be horizontal, right? Okay? Getting a little short on time, you don't need me to do that. I think you can see that. If I find when I look at your homework that you didn't see it, that's really good. Okay. Now, so and I'm going to do a little notation. Now, this curve is y equals f of x. Okay? If this is y equals f of x, we just added 1 to y, right? So now we can say that this is y equals f of x plus 1. Okay? That makes sense? Means every y value, everything you get when you do f of x, you add 1 to it and you get this graph. Okay? So we say that function is f of x plus 1. So if the function is the x squared function, then this would be the x squared plus 1 function, right? Okay? So I can write so if you had the graph of the x squared function, you'd scale it, just make your arrows, raise it up. Okay, if we want it to go down 3, well, you make an arrow 3 units long in the downward direction. You take a set of representative points and you do this. Now, if we want to do 2f of x. Okay? Because this is the x plus 1 function, 2f of x. That would be like 2x squared, right? You have two ways to represent that. You can draw the x squared graph, and then you just make it, the y values go from -4 to 4. So you just rescale the graph, right? That would do it. But we want to do it with arrows. So what I want to do is, here's where every point every y value doubles. The y value is how far you are from the x-axis, right? Or if it's negative, you know, how far you are in the negative direction, okay? Every y value doubles. Moving every point twice as far from the x-axis and in the same direction. Okay, so let's just take this point. Can I draw an arrow that shows how far this point is from the x-axis? That's how far it is from the x-axis, right? Well then, if I want 2f of x, I've got to make it twice as far. Well, to make it twice as far, I can just take one of these arrows and tack on another one. Okay? This point is twice as far from the x-axis as this one. And of course, we're going to do it in the vertical direction because our distance from the x-axis is measured perpendicular to the x-axis. If you're in a field, if you're here, there's a fence here, there's a big angry bull here, you're not going to try to run to the fence over here, you're not going to try to run to the fence over here, you're going to run to the fence here. That's your shortest path. And you don't have to have a geometry course to know that. That's instinctively what you are going to do. Okay? If you measure your angle wrong, you're dead. You know. Okay. My mother tells me, when she was a kid, she had a cousin around the same age. And one of her uncles had a farm. They spent a lot of time on the farm because there were farms back in those days that people actually owned. And she'd love to get into the bullpen so the bull would chase her, and then she was pretty agile, and you know, she'd slide under the fence, and she was still alive when she had me. And just to make her cousin cry. But I don't know how that popped into my mind, the bull thing, I guess. A lot of bull here. Now, so we can do the same thing with every other point, right? Okay? So we do this point. And we just add an arrow the same length, and we got this point. And here we've got an arrow all the way up here. It's this long. It's going to take us all the way up to here. We got this point. Okay, we got this arrow, it's this long, we go that much further, we get up to about here. Okay, here's a point, now the arrow goes down. So we end up here, this arrow goes down. So we end up here, and you know, we have another one here. And now we can draw the curve for y equals 2f of x. Okay? So this is the curve form. Should have written that up a little higher, but you understood what I said. Okay? So, we can move things up or down, we can move things right or left, we can stretch things, because that's like we took the whole axis and just stretched it out twice as far. If we did that, if we had a flexible sheet, then this graph would end up looking like this one. Now, a couple things I missed. This thing has actually a little dip here, right? So probably, I missed that dip. Okay? Probably would have been a good idea for me to include this point so I could get the dip there. Okay? But you still get the idea. Okay? That's how you stretch a function or shift it. Okay? And that's a really important procedure that nobody ever seems to understand in pre-calculus. There's rules for it. People memorize the rules long enough to take the test and forget there were even rules. Now, most of you won't end up in my differential equations of physics or multivariable calculus classes, but my students who do don't remember this either. Although, with a little prompting, it comes back to them, and then they understand why they did it. But it's not just important for students in those courses. It's important for thinking about how things in the real world behave. Okay? So we'll see more about that. Now, another thing real quick, because I want you to do this, is now we're going to have two functions. We're going to have a function f of x and a function g of x. Now I've got all this writing up there, and it wasn't a good idea to do this where I did, but we'll do it anyway. Okay, we want to do the function f of x plus g of x. Okay? Well, if we understand how to do arrows here, it's pretty easy to do this. Okay? For this x value here, and what we can do is we can just mark some x values along the axis. We probably ought to do that with white chalk. That's a start. Okay, so for this point, for this x value, here's the value of f of x, because that is the y value. If you go up the graph and across, that arrow indicates how far you are from the x-axis. That's a y value, right? And hopefully what you've done up to this point prepared you for really understanding what I just said, and I think it does. I think it'll be good. And then we go up to here, and there's the value of g of x, right? Now, how am I going to get the value of f of x plus g of x? Let's just say this value is 1. What's this value? 3? 1, 2, about 3. So what would the value of f of x plus g of x be? 4. 4. Now how am I going to get 4 on this graph? I'm going to take this green arrow and slap it up on top of this purple arrow. Whichever one's lower, I'll add it to the higher one. Purple goes lower than the green, I'll add the purple just because it looks better. But there's no reason I couldn't have taken the purple arrow and slapped it on here. I'd have ended up at the same point, right? Okay? So, I just do that for all the points. And I'm going to ask you to do that for some of the basic functions. So, how would you add the x squared to the 2 to the x graph? Take the two graphs, put them in the same set of coordinate axes, and draw the arrows. Okay? So, this would look like so. take this green arrow, slap it up on top. Okay? And then I can do the same thing for all the points, and it'll end up. So take this, put it on top here. I'll take whichever one and put it on top here. And then I can say, okay, I think my graph's going to look something like this. Okay? There's my f of x plus g of x. It's a pretty simple procedure, but you got to think a little bit to see what it means and why we're doing it. Okay? I want to get these pictures firmly established. I want you to do them right, I want you to do them completely, and I want you to work on documenting it. Okay? Some of you are doing better than others. And, you know, as long as you're working on it, we'll get there. Not that hard. Okay? You know, next week we're going to start getting into the algebra of functions. So we have to do a little algebra. There's some stuff I'll probably ask you to review. I'll probably put a PDF up there on linear functions, linear equations. So just have you review that. It's something you can pick up real quickly usually, except for the hard part, which we'll probably talk about there. Okay? Okay. Look for it tomorrow afternoon.